Hi guys, very good evening guys. Welcome back for the session, that is questionnaire session of the NEET PYQs of physics. Hi guys, welcome back. So can we start with the PYQs? So most repeated NEET previous year questionnaires, right? So yesterday we have seen the questions for laws of motion. Yes, like some of the students I have missed the class, right? The last problem once again I will try to explain, right? Let me do the question once. Yes, this was the question. So what we should do here, I need to take the components of the given question, right? First thing, in the diagram shown, the normal reaction force between 2 kg and 1 kg is, so I need to find what is the normal reaction here, like between, normal reaction between the blocks, not for the surface and the block, between the blocks I need to find the normal reaction, right? So what should I do? First thing, I should take the components, right? I should take the components. For this 3 kg block, weight is acting towards down, that is 3g, mass into gravity. Now if I take the components, no, this is my 3g cos theta and this is my 3g sin theta. Similarly, if I take the components for these 2 kg block and 1 kg block, right? Let me take like this, no? Can I write like this? This is my 2g and this is my 2g cos theta and this is my 2g sin theta. Am I correct? Now what about the 1 kg? This is my 1g and this is 1g cos theta and this is my 1g sin theta. Now I have resolved the components. Now I can directly apply what are the things given here, right? So what should I do? First thing, 3 kg block, right? Let me take the 3 kg block, 3 kg. What are the force acting? One is 3g sin theta acting in this direction, 3g sin, what is the angle given? 30 degree, right? 30 degree. Yes or no? Now one more force is acting in this direction, that is 60 Newton. Okay, 60 Newton. Now if I consider here, this is the force 2g sin theta for the 2 kg block, this will act as a normal to this 2 kg block as well as the 3 kg block, so that they will move together. So this is my normal, no, 2g sin 30 degree. This is my normal force for the 3 kg and 2 kg block. Now what about the 2 kg block now? So this is 2 kg, this is my 2g sin 30 degree. Similarly 1g sin 30 will be act as normal for 2 kg as well as 1 kg. So this is my 1g sin 30 degree, right? 1g sin 30 degree. Now for 1 kg block, the remaining last one, 1 kg block. So this is my 1g sin 30 and remaining one more force is acting, that is in this direction only. So I will keep the arrow mark as it is, like the direction, that is 18 Newton. So these are the forces, no. Now if I consider 3g sin 30 degree and 2g sin 30 degree, 60 degree, no, say 60 Newton. So which force is acting more? 60 Newton force is acting more. So obviously the block is moving in this direction. Obviously the block is moving in this direction, we can assume. So acceleration will be in this direction. So acceleration I can keep like this. Now I can write the equations easily. So what are the equations? So 60 minus 2g sine, plus no, 60 plus 2g sine 30 minus 3g sine 30, it's opposite direction, right? 3g sine 30 should be equals to, what is the mass of the block? 3 kg, acceleration is a, 3a. This is the first equation, guys. This is the first equation. What about the second equation? So similarly, this block is moving in this direction. So 1g sine 30 degree minus 2g sine 30 degree should be equals to 2a, right? Now what about the third one? This is acting in this direction, acting in the opposite direction, right? So acceleration will be in this, acceleration is in this direction. So both are in negative, no? So minus 1g sine 30 degree minus 18 should be equals to a. Now if I add everything, this 1g sine 30, 1g sine 30, 2g sine 30, 2g sine 30 will get cancelled out. 60 minus 3g sine 30 minus 18 should be equals to 3a plus 2a 5a plus a 6a. This is my equation, guys. Now we know the value of g and what is the value of sine 30. 60 minus 3 into 10 into 1 by 2 minus 18 should be equals to 6a. So what about this 1 sir, this 5 sir, 60 minus 15, 18 is equals to 6a, So what about a? A will be equals to, so 45 and then 8, 37, 20. So 60 minus 15 minus 18 by 6. I will get the value of a here, right? I will get the value of a. Now I need to find what is the force, no, like normal reaction. So I have found this much, but this is not necessary, right? Simply I can find what is the force acting here. What is the force acting? 1g sine 30, that's it. I can, if I substitute the value, I will get the answer. But most of the people are thinking like, I need to solve everything, I need to solve every equation, right? But simple, they are asking about the normal reaction force between the 1 kg and 2 kg block. It means what is the force acting here? 1g sine 30, that's it. I will get the answer. Okay, so can we go for the next question? Yeah, this was the thing I have shown. Sorry guys, this was the thing I was shown in the last class, like how to resolve it. Okay, so the next thing is, yeah, what is the minimum velocity with which body of mass m must enter a vertical loop of a radius r so that it can complete the loop? So this is a direct question, right? Yes or no? It's a direct question. Can you give the answer for this question? Can you give answer for this question? What is the answer for this question, guys? Can I zoom it out? Yeah. Yes. Now it's visible, I guess. Minimum velocity. It's root 5g r. Okay, it's a root 5g r is the answer. It's the minimum velocity required to complete a circular loop. Suppose if I consider a circle, so this is my lowest point A and this is my highest point B. So the radius of the circle will be r and center point is O. So let me take any point, and if I consider point as P or something, so this is my velocity Vp and this is velocity Va and this is my velocity Vb. So apply, this is the height, let me consider this is the height has been went. Initially it was here at the ground level. So the particle went to the height h. So apply the conservation of energy formula. So here potential energy plus kinetic energy will be equals to, what is the potential energy plus kinetic energy at the point P? So by the two equation I can find what is the minimum velocity required to complete a circular loop, that is root 5gr is the answer, guys. Okay. Next question, I will zoom it out a little bit. Yes, it's fine now. Two stones of mass m and 2m which is in the horizontal circle, the heavier one is in a radius of r by 2 and the lighter one is one in a radius of r. The tangential speed of a lighter stone in n times what is the times that of the value of the heavier stone when they experience same centripetal force. So the given thing is the centripetal, same centripetal force. The value of n is they are asking. What is the formula for centripetal force? F is equals to mv square by r. This is the formula we know, right? What is the mass is given? So for object 1 masses, let me consider object 1 mass is m and radius is the heavier one is r by 2, the lighter one is r, so it is r. Okay, so don't confuse, get 2m m and 2m, r by 2 and r, so directly don't consider it as it's, they have said that heavier one radius is r by 2, so it means for 2m it's r by 2, then for lighter one it is r. So object 2, so 2m and r by 2. Now if I substitute the values, no, f1 is equals to m v1 square by r, f2 is equals to 2m v2 square by r by 2, r by 2. Now what I can do here, so I can substitute the value, like I can take the value of 2 upside, so 4m v2 square by r. Now I can like they are saying that same centripetal force, so it is f1 is equals to f2, which means mv1 square by r should be equals to 4mv2 square by r, where r will get cancelled out, so v1 square will be equals to 4v2 square, so v1 will be equals to 2v2. So what is the value of n? It is 2, the value of n is 2, that's the answer. Yes. So only thing is we need to remember the formula and where we need to apply it. That's the thing we should be concentrated. So next question, I will zoom it out a little bit. Yes. Which one of the following statement is incorrect? So frictional force opposes relative motion. Yes, it's obviously correct, right? Frictional force means frictional force in the sense which is opposing force. So relative motion, yes, it's correct. What about the second one? It's correct. Limiting value of a static friction is directly proportional to normal reaction. Yeah. Yes or no? Limiting value of static friction is directly proportional to normal reaction. F is equals to mu n, no? So F is directly proportional to n. That's what they are saying. Static friction is directly proportional to normal reaction. Yeah, obviously this also is correct. What about the third one? Rolling friction is smaller than the sliding friction. Obviously, right? Rolling friction is smaller than the sliding friction. But what about the fourth one? Coefficient of sliding friction as dimension of length. Coefficient of sliding friction. So they are saying that mu is having dimension. Mu is having dimension. See, simple thing, guys. F is equals to mu n, where F is the force, n is also a force. If one force and force will get cancelled out, what will be the dimension for mu? It has no dimension. No dimension. So this is the correct answer. Coefficient of sliding friction has dimension, they are saying, but it has no dimension, right? It has no dimension. Go for the next question. Okay, I guess you can do it simple by resolving the components. So law of motion, that is 2022. Yeah, four forces are acting at a point P in equilibrium as shown in the given figure. The ratio of F1 to F2 is 1:x, where x is equal to, they are asking. Okay, I can find now here. First thing, I need to resolve it. So F1 is directly given, like no need to resolve anything. F1. What about this case? 2n, like 2 Newton, 45 degree. So it will be my 2n cos, I can write like this, 2 cos 45. And what about this case? This is 2 sin 45, 2 sin 45 degree. What about the F2? F2 is given as it is, no need to take the components. What about the 1 Newton, 45 degree? No. So this is my 1 cos 45 degree, and this is my 1 sin 45 degree, 1 sin 45 degree. Now everything are in equilibrium, no. So x and y I can take separately. So what about this? F2 will be equals to 1 cos 45 degree means 1 by root 2 plus 2 cos 45 degree means 2 by root 2. This is about my F2. What about F1? F1 plus in the same direction, 1 by root 2 is equals to, in the opposite direction, 2 by root 2, right? And they are asking what is F1 to F2, the ratios they are asking. So here, first thing I need to calculate it, no. F2 is equals to 3 by root 2. And what about F1? F1 is equals to 2 by root 2 minus 1 by root 2, which is nothing but 1 by root 2. So F1 is to F2 is equals to 1 by root 2 is to 3 by root 2. So root 2 will get cancelled. So answer is 1:3. That's the answer, guys. Yeah, 1:3 is the answer. Yeah. The next question is, an electric lift with a maximum load of 2000 kg, that is lift plus passenger, they are saying, is moving up with a constant speed of 1.5 meter per second. What are the given things? First I will write it here. So maximum load is given 2000 kg, okay, and it's moving with constant speed. A frictional force opposing the motion is 3000 Newton, okay, 3000 Newton. The minimum power delivered, okay, minimum power delivered. So power formula, work by time, or else I can write power is equals to force into velocity. So velocity is given. What about the force? Force I can find, no, 2000 kg. So 2000 total force I will write here. Total force should be equals to 2000 into, what is this? Weight, no, so 10 mg. M into g plus, what about the opposing force? 3000, which means 20,000 plus 3,000, which is equals to 23,000, right? 23,000. So I got what is the force. So I can substitute the value of force in power equation. Force is 23,000 into velocity is 1.5. That's it, guys. You will get the answer. You will get the answer for the power. So in watt. So it is, answer is 34,500. Can we go for the next question? Yeah. A mass M is attached to a thin wire and whirled in a vertical circle. The wire is most likely to break when? So when I take a weighted object, no, if I try to rotate it, so when it goes up, it will try to come down, right? But when the object is down, it will try to go as much as down possible. That time the wire will elongate and it will try to break it now. So what is the given things here? The wire is horizontal. In the horizontal direction, it won't break, but the mass is at the lowest point. One thing we can keep now, wait, and the inclined angle at the 60 degree. No, this also won't come. This also won't come. The mass is at the highest point. Highest point in the sense it will try to come down. So answer is the mass is at the lowest point. The mass is at the lowest point. So the next question, yeah, block of mass 10 kg moving in the direction. Is it visible now? Yes. Moving in the direction of a constant speed, yeah, 10 meter per second square. Speed is equals to 10 meter per second, 10 meter per second is subjected to retarding force. Force is equals to, F is equals to 0.1 x joule per meter during its travel from x is equals to 20 meter to 30 meter. So work done will be equals to, right, work done will be equals to what they are asking, kinetic energy, right? So its final kinetic energy will be, right? So work done, what is work done? Force into displacement. Force is given, the displacement in terms of x they have given. So integral of 20 to 30, what is this? 0.1 x, 0.1 x. So 0.1 x square by 2 from limit 20 to 30. 20 to 30. Then it is 0 into 30 into 30, that is 30 square by 2 minus 0.1 into 20 into 20 divided by 2. This is what I need to do. I need to substitute the values. So 1 sir, and this is 15 sir, 1 0, and this 1 0 will get cancelled. 45 this one. So this is 1 sir, this is 10 sir, and 1 0 will get cancelled. Minus 20, which is 25. So this is what work we got. No. Now what about the remaining things they have said? The block of mass 10 kg moving in the direction with a constant speed is subjected to retarding force. Retarding force they have given, but the kinetic energy, no. Kinetic energy is equals to half mv square, where mass is 10 kg, half into 10 into velocity is 10 meter per second, that is 10 square. So this 1 sir, this 5 sir, this 500. So 500 retarding force, no, I mean retarding work has been given, that is 25. So 500 minus 25, which is nothing but 475. So the remaining thing is 475 joules. 475 joules. That's the answer. So only thing I need to find what is the work done in retarding force and work done during the travel, that is kinetic energy. If I subtract those things, I will get the answer. That's what the question given. So okay. The potential energy of a system increases if work done. It's a direct question, right? I'll zoom it out little bit so that you can see. Upon the system by conservative force, upon the system by the non-conservative force, by the system against the conservative, against the non-conservative. It's a direct question, guys. You can say directly upon the system by conservative force. So potential energy of a system increases if the work is done upon the system by a conservative force. That's the thing. Okay. So we have seen some questions today. We'll come up with the few more questions in next session. Okay, next session will come. Okay guys, bye bye. We'll meet in the next session. Bye.